So let's move on into CMUs, or concrete masonry units. These are masonry walls. You see them in the dorms, you see them in basement walls, you see them elevator core, you see them as walls for both wood, steel, and concrete, or wood, steel, and masonry type buildings. It's very common. This is what they look like. You've probably seen them at Menards or Home Depot or out and about. There's some variations on this, but essentially it's a large block made of mortar, and it's got cavities in it, or pores in it. In 1866, they came up with some techniques for making this type of block. Of course, at that point it was wooden molds. It's a pretty dry mixture of sand, cement, and water that they pushed in by hand. Nowadays, it's basically the same thing, but we have some other small aggregate, and it's molded under pressure. It's if you go look at these, you can see that it's got kind of almost like a Rice Krispie, or a little bit. You can tell it's a real dry mix with not a lot of paste. Okay? So go take a look at one up close next time you're at Home Depot or Menards. Or if you're in one of the dorms, you probably have seen plenty of those. Okay, so concrete brick is ASTM C55. That's the specific, or the testing standard. Just like for concrete, we'd have C150, things like this, okay? Or cement. Typically, these are going to be solid units for exterior walls, things like fireplaces for concrete brick. We're not going to worry about this right now as much. What we're more interested in are the hollow CMU units. They have to meet ASTM C90. They're usually only about half void and half solid. Portland cement, water, and aggregates. There may be some admixtures, etc. in there. All right, so like we've been doing with wood and what I talked about with brick, there's nominal dimensions and actual dimensions. So nominal, we'd call this it's an 8-inch wide, 16-inch long, and 8-inch tall standard CMU unit. These are actual dimensions here, same thing. You've got a mortar band, so that if I wanted to count up the blocks, I would be able to use the nominal dimensions and not have to attribute the mortar piece. There's a certain, for an 8-inch block like this, there's a certain minimum face width for the shell and a certain minimum for the web. So 1 1/4 on the outside, 1 inch in the web, which is that middle piece. So here's some examples, a bunch of different examples of types of CMU units. The one I showed on the previous page is the one you see the most. You'll also see the 3-core model out there. These other ones are kind of specific to different applications. One that we'll see here that you may not be as familiar with is a lintel block for bond beams. In other words, where I'm going to use this is at the very top of the wall, or if I need a lintel. So let's say I have a wall and I've got a door opening here. I need a lintel or a beam, bond beam, and I can put this type of block and then fill it, and it can, if I put a bunch of them together, you can see I get a continuous fill in here of concrete or mortar and reinforcement. So when I want to turn this into more of a beam unit, this keeps it continuous. Here's some more of these guys, different variations. There's pilasters that can be used as well. So basically, if you're looking at a concrete masonry block that has some type of hollow shape, you're looking at a CMU. Here's one you can see the lintel or bond beam, right? We can have columns made out of masonry block. That's totally acceptable, right? And you can very clearly see each of the lintel type ones in this particular picture. Okay, so an important part of this is mortar and grout. The mortar allows us to take up some of the irregularities between block or brick. it seals between them, right? So it kind of allows for full bearing, right? So that I don't have bearing just on the tips of some, irregularities, but it also seals them, sticks them together, and it looks nicer if we do it well. So early on, mortar was made clay or maybe a clay straw mixture to fill cracks. And then it became then it became more of a limestone reaction, right? Or a cementitious type reaction. And by the 19th century, we were using Portland cement, sand, lime, and water. And we started to have a much stronger mortar, bordering more on a mortar like we'd have today. Ours are even higher strength at this point because we don't want the mortar to be the weak, a real weak link in this process. So it's important that we have a strong mortar. You can see a stack of CMU here, and your mortar obviously are at these joints. Right. The mortar has to conform to ASTM C270. You guys have access to the ASTMs through our library, through the Compass website. So while you're in school, here's a good time if you want to take a look at some of those without having to buy them. That's a great way to do it. And I believe you can actually download them if there's some you want to use. Similarly, we've got exterior use, interior load bearing, and then non-load bearing, basically architectural type walls. And we have to have a more robust mortar if we're outside for durability purposes. Admixtures, you can have admixtures in the mortar. You can have it quick set, slow set, more flowable, things like that. Typically the mortar is prepackaged, just like the mortar grout that you put between your tiles in the bathroom or the kitchen. Prepackaged, you can get it in different colors. It has to follow the testing and specifications I mentioned earlier. It does need to cure. It's a concrete, or it's a cementitious type product, and it does have a shelf life. In other words, it's not going to behave the way you want to after a certain amount of time. So very similar to concrete or the ready mixed bags that you can get at the home store. All right, you can see some that match the brick, some that are contrast to the brick, etc. So here's the blend. This is the joint coming out and blending, sort of. Color contrast. This looks very much like a veneer, to be honest. Very thin, smooth brick. And a couple others. Now, grout is similar to mortar, but this is what we use to fill the hollow parts in our CMU, and I may have reinforcement in there as well. Okay. Grout is also what I study for post-tension structures. It's the same type of mixture, it's just got different properties because I'm looking at fluidity and pumping through some really tight spaces in a post-tensioning tendon, whereas this is to fill these hollow cavities. They'd be vertical in this case, or in those bond beams I showed you, or lentils, they would be a horizontal fill. There is usually, so it's got sand in it. Grout is essentially cement and water and may have some fine-grained or coarse-grained materials in it as well. Sand, these have to conform to C476. So the mortar versus the grout have different conformance standards from ASTM, and that's what you would follow that is based on the application that we're using here. There's nothing in the code about low lift or high lift grouting, but you'll hear it used. If I've got just a 5'4" or less, they typically, we call that a low lift. High lift would be if I wait until I'm all the way up to something like 24 feet before I grout. So I can grout in stages as I go out. The higher you go, just it becomes a little more complicated with filling that space and making sure you have it consolidated. Okay. So that grout really ties all this together, and when there's reinforcement in there, it's also forming the part of this final wall system to where you can start to see it looks very much like a reinforced concrete wall. Okay, let's talk about masonry joints. So You may just think of it as they put the stuff between the bricks, but, and this is, as a structural engineer, not huge that you know this, but it's interesting, much like all the species of hardwood and things we covered in that section. So here's some names of all the different ones. You're going to see flushed or standard concave. Um, you can have it way concaved or recessed. Make a V, all different types of things. And it takes a different tool if you're making the V versus some of the others. Okay. So here's some bricklayers going ahead, and you can see they have some different types of bricks here. Laying this. This is a trade that is time consuming, and it's really an art to be a good bricklayer. Here's what I typically see the most are these concave type joints. When you run the tool through here, you get a nice, smooth, rounded type joint. Here's one that they've had the V tool. These joints are completely recessed back. A little bit more of a operation here. This would be more common, I think, with veneers. Here's flush. In this case, not as pretty, but this is a pretty old wall. Here's a close-up with the V tool. Okay. Here's a more unusual one where the brick or the stone is actually recessed and the joint sticks out. Interesting architecturally, easy to chip that stuff off because it's basically unreinforced mortar. And of course, here's some cleaning afterwards to get everything, the dusted surface off the masonry or the brick. All right, I'm going to stop on that, and then we'll do the next section as a separate video.